So in this session we are going to start chapter number 19. It's exponential and log functions. Before starting today session, first you need to understand that how to derivate exponential function, right? So on your right side you can observe that I have pasted the working formulas from the book. It says that the differentiation of exponential is exponential, but then you need to derivate its power. All right, what did I say? The differentiation of exponential is exponential, but then you need to derivate its power. So for the practice, I have pasted example 4 here. First we are going to start with the example, and once you are clear about the concept that how to derivate the exponential function, then we are going to start the book questions. All right. So example first part, it says differentiate e to the power 5 minus 2x. Alright. The differentiation of exponential is exponential. That means I'm going to write down e to the power 5 minus 2x. But then we need to derivate its power. So the differentiation of power is the derivative of 5, it will be 0 because it is a constant, right? The derivative of minus 2x, it will be minus 2. So the final answer, it will be minus 2 e to the power 5 minus 2x. That is your first part answer. So repeat with me, what did I say? The differentiation of exponential is exponential, and then you need to find out the derivative of its power. Right? Now starting with part B. It says e to the power x square plus 1. X square plus 1 is the power of exponential. So what is the differentiation of this part? First, the differentiation of exponential is exponential. So I'm going to repeat the same question. And then I need to find out the derivative of its power. So the differentiation of x square, it will be 2x because the differentiation of 1 is 0. Now we need to write in this form 2x e to the power x square plus 1. That is your answer. Similarly, if I start with the third part, part C. Alright. It says e to the power x plus 1 and whole power q. Alright. So now you can observe that we have a power here, right? So first we need to derivate the power, and we know very well that how to derivate the power. It's very simple. First we need to write down the power and subtract 1 from the power. So 3 minus 1, it's 2. Alright. So power is derivated, and now we need to derivate the function. The function is what? The function is e to the power x plus 1. So the derivative of e to the power x plus 1 is e to the power x, because plus 1 is a constant and that derivative will be 0. Now if I write the equation in proper form, so it will be 3 e to the power x times e to the power x plus 1 and his whole square. That is your answer. Alright, so I hope now you are clear regarding the differentiation of exponential function, and now we can start with the exercise question. Alright, so moving on towards the exercise, it's 18.1 of your book, and it's question number 8. Question is same, differentiate the following with respect to x, and we are going to begin with part C. Part C we are going to attempt, part E we are going to attempt, I we are going to attempt, and K and L. These 5 parts we are going to attempt in this session, but it will be good if you give it a try by yourself. So let's suppose I will begin the question with C part. It says e to the power minus 2x. So what you need to do, you need to give it a try first, and you have a time of 30 seconds to give it a try. So start. Alright, so what I expect from you, you had done is the derivative of exponential is exponential, and then the differentiation of its power, that is minus 2. So finally the answer is minus 2 e to the power minus 2x, that is your answer. Alright, after part C, start with part E. It says e to the power 3x plus 7. Give it a try. Time is 40 seconds, so start. Alright, so it will be very simple. The derivative of e to the power 3x, e to the power 3x, and then the derivative of power, it will be 3, so that is your answer. After that, part I, it says e power x plus 1 divided by e to the power x. Alright, so you have a time of 2 minutes. So how you are going to attempt this part, first think about it, and then I will explain. So start. Alright, before differentiation this function, what I will do, I will arrange the equation, and arrangement I meant that e to the power x plus. When you shift e power x in the numerator, it will change its sign, so that will be e to the power minus x, right? And now I have properly arranged my question. Now I will start differentiation. So the derivative of e to the power x, it will be e to the power x, derivative of x is 1 plus. Derivative of e to the power minus x is e to the power minus x, but this time the differentiation of minus x, it's minus 1. So your final answer, it will be e to the power x minus e to the power minus x. That is your final answer. Alright, so after part I, let's start with part K. It says 8e to the power 1 over 4x plus 1 over 2e to the power 6x. Again, you have a time of 2 minutes. Take your time, and then I will tell you the answer. So start. Alright. Firstly, the differentiation of e to the power 1 upon 4x is e to the power 1 upon 4x, and now the differentiation of power. So differentiation of 1 over 4x, it will be 1 over 4. Similarly, I will do the same with the second part. The derivative of e to the power 6x is e to the power 6x, and now the differentiation of power 6x differentiation, it's 6. Now I have differentiated both the functions. Now I need to simplify it. 4 1s are 4, 4 2s are 8. So it will be 2 e to the power 1 over 4x plus 2 1s are 2, 2 3s are 6, 3 e to the power 6x. So that is your final answer. Alright, I hope that it is clear. And now we are going to start with the last part. It's part L. It says 1 over 3 e to the power 9x minus 2 e to the power q. You have a time of 90 seconds to give it a try, so start. Alright. Similarly, it will be 1 upon 3 as it is. The differentiation of e to the power 9x is e to the power 9x, and now we need to find the derivative of power, that will be 9 minus e to the power 3 is constant, right? E to the power 3, it's a constant. You can find the value of e to the power 3 from the calculator. And we know that the differentiation of constant is 0. So that is why we are writing 0 here. 2 is constant, e to the power 3 is constant. This whole term is a constant, and the differentiation of constant is 0. So the leftover part we have 3 1s, 3 3s are 9. So it's 3 e to the power 9x, and that is your answer. Alright, now moving on towards the next question. It's question number 9. Alright, using the rules of indices, express the following as e to the power ax plus b, hence or otherwise differentiate with respect to x. So your answer must be in this form, e to the power ax plus b. Alright, so in the first part it says e to the power 3x times e to the power x minus 1. Before starting this question, if you observe that we have same bases, right? The base is e, the base is e. When you have same bases and they are multiplying, this dot is basically represent multiplication, right? So when you have same bases and they are multiplying, means that we are able to add their powers. So if I add their powers, so it's e to the power 3x plus x minus 1. I did not differentiate the function, but I arranged my function, so it helps me with the differentiation process. So now it will be e to the power 3x plus x, it's 4x minus 1, right? And let's suppose I equate it with y, so it will be easy for you to understand the differentiation. Now you have a function y equals to e to the power 4x minus 1. If you need to derivate it, so dy over dx equals to, differentiation of e is e to the power 4x minus 1, and now we need to derivate the power. The differentiation of 4x, it will be 4, and that is your answer. Alright, so first you need to write down this solution in your copy, and you have a time of 40 seconds, so start. Alright, for part B, it says y is equals to e to the power 2x plus 3 divided by e to the power x. Alright, I am labeling it with respect to y, but that is not mandatory. You can start differentiation as it is, but I think that it will be more simplification. That is why I am using y here, but it is not mandatory that you are going to use it in the question as well. You can start differentiation directly. So first you need to give it a try first how you are going to derivate the function, and for that part you have a time of 2 minutes. Give it a try and then I will explain. So start. Alright, if you think that to apply u upon v here, so it is not wrong, you can apply, but that will be lengthy. And to make it shorter, that is why it says using the rules of indices. What we are going to first, it is e to the power 2x plus 3. When you shift the denominator e to the power x in the numerator, so it will change its sign. So plus x, it will be minus x. Alright. And in terms of indices, we had learned that if you have same bases and they are dividing, so power changes its sign. Alright. So now it will be y is equals to e to the power 2x minus x, it's x plus 3. Alright. Now the equation is in simplified form. Now we can differentiate the equation. So dy over dx is equals to e to the power x plus 3, and the derivative of power, that is x, is equals to 1, because 3 is constant, it will be 0. So there is no use to write 1 here. So that is your answer. After that, moving on towards the next part, it's part C, e to the power 1 minus x and its whole square. Alright, So how you are going to start with this solution? First give it a try. You have a time of 2 minutes for this question and then I will explain. So start. Alright, firstly I will apply the power here, so it will be e to the power. Power multiplies with power, so it will be e to the power 2 minus 2x. Alright, and that is equals to y. Once you had multiply with the power, now you can start differentiation. So dy by dx y dash is equals to the derivative of exponential is exponential and then the derivative of power it's minus 2. So answer is minus 2 e to the power 2 minus 2x. And then the last part d, it says under root e to the power 3x. Again you have a time of 90 seconds to start. Alright, firstly I will equate it with y is equals to e to the power 3x and the meaning of root is power 1 upon 2, right? So now it will be equals to y dash. First we need to write down the power, right? Then we need to subtract 1 from the power. Alright, so now it will be y is equals to e to the power 3x divided by 2, right? Because power multiplies with the power. And now we can start the differentiation that y dash is equals to the differentiation of exponential is exponential and then the differentiation of its power, so it will be 3 upon 2 and finally you can say that it's 3 upon 2 e to the power 3 upon 2x, that is your dy over dx. Alright, so I hope that it is clear. Moving on towards the next question. It's question number 10. Again we need to derivate the function with respect to x and we are going to start with part b. It says x plus e to the power x and whole power is 5. Alright, so how you are going to derivate that function? I will start with part b and then I will tell you to start with the next part. So first we need to derivate the power, and it will be 5. First we need to write down the power, then subtract 1 from the power, it will be 4. And now we need to derivate the function which has power. So the derivative of x is 1. The derivative of e to the power x, it will be e to the power x. Alright. So now the final answer is 5, 1 plus e to the power x, and x plus e to the power x with the whole power 4. So that is your answer. Alright, so now we need to derivate the power first and then the function. So I have done with the part B, and what you need to do, you need to start with part B here. So it says e to the power x and sine x. Alright, so as a hint, I am going to tell you that you need to apply u into v here, because these are the two functions and they are multiplying. Alright, so give it a try first. You have a time of 3 minutes to start the solution, and then I will tell you the answer. So start. Alright, so firstly I will assign u and v here. So I will say that u is equals to e to the power x and v is equals to sine x. So derivative of u is e to the power x and derivative of v. The derivative of sine x is cos x, right? Now we are going to apply the working formula, which says u derivative of v plus v derivative of u, which is e to the power x. And now I can take common e to the power x here. So the leftover part is cos x plus sine x, and that is your answer for dy by dx. Alright, now after part D we are going to start with part F, and part F it's e to the power minus x cos 2x. So again you need to apply u into v here. So first give it a try by yourself. Time is 2 minutes, and then I will explain. So start. Alright, so I will say that u is equals to e to the power minus x and v is equals to cos 2x. U dash is e to the power minus x and the derivative of minus x is minus 1. Alright, and v dash is minus sine 2x. Now we need to derivate the angle. So the derivative of angle 2x, it is equals to 2. So if you had find the correct derivative of e to the power minus x and v cos 2x, then it is very good that you are on the very good pace, right? And now we are going to apply the working formula which says u e to the power minus x, derivative of v minus 2 sine 2x, u derivative of v plus v cos 2x, derivative of u minus e to the power minus x. Alright, now you can take common here and that is e to the power minus x because it is present in both of the expressions. So e to the power minus x is common and the leftover part is minus 2 sine 2x minus cos 2x. Alright, and furthermore what I can do is I can take negative sign common. So it will be minus e to the power minus x and inside the bracket I need to change the sign to sine 2x plus cos 2x. That is my final answer. Alright, so I hope that it is clear to you, and what you need to do as a homework, you need to attempt part E of this question. So if you can do it, that will be very good, and it is a very good practice if you can do it correctly. Make sure to check your answer from the book. After question number 10, moving on to the next question, that is the last question of today's class. It's question number 11 and it is also 6 parts, but in this case you can observe that now we need to apply q upon v here. So let's start with part A. It is e to the power x divided by 1 plus x. Firstly, you need to assign u and v here, so I'll say that u is e to the power x and u dash is e to the power x. V is 1 plus x and v dash is equals to 1. Right? We have all the value of u, v, u dash, v dash. Now apply the working formula. It says in the denominator we have v square and v is what? It's 1 plus x whole square. It says v derivative of u minus u derivative of v, which is 1. We can take common here, so e to the power x common, and inside the bracket we have 1 plus x minus 1. This minus 1 is because of this exponential, because it is already taken as common. And in the denominator we have 1 plus x to the power square. We can start simplification with plus 1 and minus 1 cancels. The leftover part is x e to the power x divided by 1 plus x and its whole square, that is your dy over dx, and that is your answer. After part A, let's start with part B. We say that x divided by 1 plus e to the power minus x. So give it a try. You have a time of 2 minutes and then I will explain. So start. Alright, so firstly, like the same question, first we need to assign u and v here. So u is x and v is 1 plus e to the power minus x. U dash, the derivative of x is 1, and v dash, derivative of e to the power x is e to the power minus x, and the derivative of power will be minus 1. Now we need to apply the working formula, which says in the denominator we have v square, so it will be 1 plus e to the power minus x square. Now the formula says v is what? 1 plus e to the power minus x. V derivative of u, it's 1, minus u derivative of v, it's minus e to the power minus x. You can simplify a little bit, so 1 plus e to the power minus x minus minus plus x e to the power minus x divided by 1 plus e to the power minus x and its square. Alright, so that is your final answer. We cannot simplify it further. And as a homework, what you need to do, you need to attempt part E. Alright, so I think that is quite enough for today class. I hope that you have a clear idea how to derivate the exponential function. It's very simple. The differentiation of exponential is exponential, and then you need to derivate its power. So it's quite simple and easy. Make sure that you need to give it a try of your homework, and you can attempt rest of the question as well, and you can check your answer from the book. That will be very good practice. So make sure to submit your homework on time, and if there is any problem, just drop me a message on the portal and I will get back to you as early as possible. Alright class, so it's quite enough for today's class right now. See you in next class. Take care and Allah Hafiz.